It's time for the final video. Let's get it on. So we can use a min and max value here, oh my gosh, to control the maximum zoom in and zoom out range. Let's do that now. We'll create new variables, min zoom and max zoom. Not really sure what these should start out as, but we'll compile and set them to some values and see how those look. Start with 100 on the minimum zoom, and the max zoom, I'll say 1000. Then to make all of this a little bit cleaner, since we're about to start doing a lot here between our timeline, setting the target zoom, as well as adding restrictions and constraints around zoom itself, let's make a new function to handle all of this for us. I'll make a function called adjust zoom. We'll receive the same input, a float named amount, that we want to adjust our zoom by. So we'll bring in our target zoom, hold control to get the getter, and we'll add these together to get our new raw target zoom before any of our constraints are added here. Next, we'll pull from the result of this and use the clamp, and I'm going to use the clamp float. And here's where we can use our minimum zoom and the maximum zoom to clamp within those values. So by placing the minimum zoom in the min, it cannot go below our 100 value here. And then the max zoom we'll bring in, apply it to the max, and now we cannot go above the 1000 value here. Finally, we'll set the target zoom, bring the execution pin over, pass the return value into the target zoom. Now we just need to use this in our event graph. So we no longer need any of this. We're doing it in our functions here. So we'll delete those three, bring in our adjust zoom function, bring the execution pin over, bring the amount into the amount for the zoom to be adjusted by, then execute the play from start. So this looks a good bit cleaner, and we now have proper constraints to avoid any wild zoom. Let's give it a shot. All right. We can zoom in a bit far still, but not far as we used to, and zooming out is still a little close. So let's try 200 instead of 100 and 2000 instead of 1000. Play again. Yeah, I mean, if you wanted to get really into your character and just see some detail on that at some point, that could be worth allowing that close of a zoom up. And 2000's pretty far out. Probably wouldn't really want this much distance as your max zoom, but for the case of debugging and working on things, being able to zoom out pretty far could be pretty helpful. And other than that, we've got a pretty solid little top-down character at this point. It can move around, rotate the camera, get error messages when your mouse is outside the window, and click anywhere it needs to get points of where the mouse is. And it's all very decoupled from the player controller. It would be very easy to make additional characters tied to the same controller and provide different functionality under the same events. The only thing really left to do is to make an actual projectile to fire at these points that we're creating. So let's do that real quick, just to bring it all together. I'll right click in our folder again, go to Blueprint class, and create an actor. I'll call this BP underscore projectile, and open it up. I'm going to go to add component here, and search for projectile movement. We'll add this in here, and we'll also want a static mesh, as well as a box collision or some sort of collision. While we won't be making use of this, this is what you would want to actually have it colliding with things. I'll make that the scene root as well. Static mesh, we'll go with the translate arrow handle. It's projectile-like, and it'll get the job done for now. The box I'm going to leave alone. We don't really need it for anything we're doing, just giving the proper hierarchy for the setup of it. And I'll pull this projectile back, get it a little bit more even with the actual center of the blueprint. And maybe we'll give it some materials here. All right, so now we got a nice little bronze arrow of sorts. Compile this, save, and we'll need a direction variable to load in the velocity or the direction we want it to go. Compile this, and in the event graph for the begin play, we can pull the projectile movement in and set velocity. And we'll bring these execution pins over like this. And for the sake of cleanliness here, I'm going to create a new function called calculate velocity. It'll take in a vector called direction. And it'll be pretty simple. We're going to use the projectile movement, get the max speed, and we will multiply this by the direction that we're receiving. So we can bring this in alignment there, and it would probably be a good habit just in case we're receiving a direction that is not a unit vector to normalize it to make sure we don't get any wild results here. And pass the normalize in instead of the raw direction just to help keep things a bit more sane. Bring this down a little bit to give room for the execution arrow, and in the outputs, well, we will return velocity. Velocity. Bring our product into there, and now we have a velocity based on the projectile movement's maximum speed and the incoming direction that we'll receive from our direction variable. And we're going to make the direction variable instance editable and expose on spawn. So we can set this direction as we're spawning a projectile, and then it'll create the velocity that it needs. Bring it into our begin play, and again we can make this pure, drag velocity into velocity, pull in our direction for the direction, highlight these, hit Q to even them up, and that looks nice, yeah. So at this point we should be able to head into our BP character, and we've got our request primary attack here. I'm going to remove the draw debug point and create a new function called perform primary attack. And for the case of this, I'm going to spawn actor from class. It's going to be our BP projectile, and the transform will create from our get actor location. Using our own actor's location, we can make a transform and plug this in as the projectiles transform. Then for the direction, we'll actually want to receive this as the vector target point. So we'll connect the execution pins here, bring this down a little bit to make some room, and to get the direction, we can use our get actor location and the target point here to say get unit direction of type vector from our actor location to our target point. And where can this really go? Ah, these wires are crossing all over the place. Sure, this'll work. Plug this into our direction, and now we're getting the direction from our actor location to the target point and spawning a projectile. Let's see what this looks like so far. Save everything, compile. Oh, wait, we did not. We only made the function, so let's actually use the function. Bring it in here, connect the execution pins, target point to target point, save, compile, and play. All right, yep. Oh, we're using it to move around the map. Interesting use of movement. We have some collision there that's pushing the character a little bit, and they are just falling, and they have no velocity. And that is because of a few things here with the BP projectile. First of all, let's head into the box. Collision. It's set to overlap all dynamic, so that's good for us. Static mesh, block all dynamic. I'm going to say no collision at all on the static mesh. Then in the projectile movement, we can search for gravity. Projectile gravity scale 0. I want no gravity on my projectile. And then finally, max speed, currently set to 0. Going to set this to 1000. Compile, save, and let's look at it again. Yeah, there they go. This is much better. The projectiles are a little difficult to see. Let's see. And they're not facing the way that they're moving. So again, in the projectile movement, velocity, rotation follows velocity. If true, this projectile will have its rotation updated each frame to match the direction of its velocity. And that sounds good to me. I'm going to click that. Is there anything you'd do differently? Leave a comment below explaining what you would do better than me. I'd love to hear from you. And then for the static mesh, I'm going to update the scaling on this a little bit just to make it a little bit easier to see. 5 on the X is not what we want. 5 on the Y, that looks like it would be good. 5 on the Z, it's a big chunky projectile. Play this, there we go. That's much easier to see. And it is spamming a bit because it's just activating off of the triggered of the primary attack. And you'd want to handle this on your own within the BP character, whether or not it can actually perform a primary attack. For now, I'm going to drop this menu down and trigger it from started rather than triggered. So now it would only happen when the input is started rather than while it is being triggered. So we can head back over, play it again, and now it's only happening on a single down click. I can't hold and spam it anymore. But this is pretty solid. We're shooting little projectiles out, we're moving around, our character's looking at where we're looking with the mouse. We can rotate, we can move, we can zoom. You've really got all the foundation you need here for a little top-down shooter character. Now that we have everything in a good spot, let's clean everything up a little bit and make sure it's nice and tidy for anything we do moving forward. In our player controller, we made a little bit of a mess in the get cursor ground position. And we also have a rough case of when we failed to convert the mouse location to world space as well. If we currently look at how this is working, when this fails, we don't actually return any value, but at the very least, we could be returning the cached cursor ground position rather than just an empty vector. However, the biggest cleanup is going to be in this bottom section down here, where we are getting the distance to the ground from the camera. So I'm going to encapsulate this into its own function called calculate distance from camera to ground. So I'll pop back over into this function, grab everything here, and cut it out. Go back to our calculate distance that has a lowercase d, fix that, and paste it in. And we're going to need a few things here. We'll need 3 inputs, 2 vectors, and 1 float. First vector would be the cursor location. Second would be the cursor direction, and the final would be the ground Z. Now if we hook these in, the cursor location, the cursor direction, and finally the ground Z, which is moving here. We can delete this. We no longer need the actor Z. We can plug this in. I'm going to move these down a little bit, move these up a little bit. That looks a little nicer to me. And for the return values, I'm going to do something very similar. I'm going to return 2 vectors and a float. The first is going to be out cursor location, and then out cursor direction, and finally distance to ground. If we pull this off over to the side here, we can plug this in to the distance from, we'll need to remove this divide, create a new one, bring in the Z here, and plug this into the distance to ground. And then cursor location, out cursor location, cursor direction, out cursor direction. And I'll just tidy this up a little bit more. And what this will allow us to do, having these outs, is have a slightly cleaner implementation of this function in here. Since we were breaking these previously and then also stringing them into here, this will avoid having to cross those through when we use this function, calculate distance from camera to ground. And again, I always forget to make it pure until I see it with those execution pins. We can bring this in here, lower this down to make it a little bit more even. World location to cursor location, world direction to cursor direction, bring this down 1. And you can already see how these lines are kind of going through it, right? Well, we don't really need to do that anymore. We can bring the cursor location out into this here and the direction into this here. And now that really cleans up the look here for us. I'm going to highlight these, hit Q, even them out a little bit. Highlight these, hit Q, even them out a little bit, and bring all of this over just a bit. Pull this up here and bring the distance to ground, and I'll even those out as well. Tighten them up a little bit. Alright, this looks much nicer, much cleaner, easier to follow. And now finally we need the get actor location from the get controlled pawn get actor location. Split this struct for the Z value, and there we go. Finally, we can copy and paste this control node, bring it up here with this error handling, and bring in the cached cursor ground position as a getter to fill that in the case that we are ever unable to reach the ground and figure out where the cursor is. We'll just keep going with the last thing we knew to be a good answer. And now this looks so much cleaner, easier to follow, and I like it so much more. Now finally, we'll want to actually make sure it's still working, and it appears to be so. Well, yeah, we know that we're getting those good values still when that happens, but otherwise, yes, everything appears to be looking like it's working just the same as it did before. And now we can close out of these and add some comments around here to make this look a little bit nicer. So right now, it's kind of hard to follow. There's just nodes floating out, sitting around. You've got the red nodes, which do help, but without really zooming in and reading these smaller fonts, you don't very quickly know what is what. So for the begin play, I'm going to highlight this, hit C to bring a comment, and call this initialization. Now we have a nice little initialization section here. Do the same thing for tick, C, call this tick, move it up, and then we have movement here, C, movement, C, attack. And for both of these, I'm going to put them into a single comment called camera. And now I think that just looks so much better. You're able to read it so much more nicely. You got this big font here rather than the small fonts here. And the high level view of this whole blueprint is now much more easily digestible. And the same thing for character. C initialization, C movement, look at, attack, and camera. All right, and you could color code these if you wanted to, make them stand out in different ways, but I'm good with this for now. I think this already helps so much, just having it organized under comments like this. And one quick note around the get cursor ground position. It is nice to have this all encapsulated into a nice little function like this in case you ever want to adjust the formula for how you get the cursor ground position. For instance, in my case, I don't plan on having varied level of terrain. Everything is going to be at this character z-axis, right? So I never need to worry about that changing. If there's a hill or a slope where your mouse is trying to click, if the character is downhill and you're clicking on top of the hill, this is not going to work. It's going to try to just shoot it directly into the hill. But you can instead use a raycast as your get cursor ground position, shoot a line trace by channel to your terrain objects, get the hit point of whatever it collided with, and use that z value as your ground instead. Or, well, you don't even need to do all this math at that point. The line goes down, you have the exact location of where the ground was hit by your ray trace, and then you just return that. However, that's also involving physics instead of just math. So I think this is a little bit better for me and my approach that I'll be taking. I know that I'm always going to be on this plane of Z as my character moves. I can trust that this will be a constant in my game. If you're going to have terrain that varies up and down, you're probably going to want a raycast and avoid all of this math. Though, if you're going to have the same Z throughout, I think the math would be a little bit faster, a little bit better. You don't have to bring any physics or ray tracing in, and you can get the same result. Alright, well now you have a little top-down character that can run around, shoot things, and you can build a lot around this, build some maps, enemies to interact with the projectiles, and you can have a game going in moments. I hope you learned something. I had a lot of fun making the video, as well as learned a lot along the way. If there's anything you'd like to see more of, or a different topic you'd like to hear more about, let me know in the comments below, and I'll look into making a video about that topic for you. In the meantime, like, subscribe, comment about something else, like why you hated the video instead, and follow my newsletter in the description to get access to any builds that I put out for games that I'm working on. And I'll see you next time.